Hi, today we're going to be working with 7.4 hypothesis testing for proportions. So again, we're continuing the whole idea of the chapter, which is hypothesis testing. Just like with confidence intervals, we're going through the same process of with sigma given, with sigma unknown, and proportions. Um, We're continuing the thought of hypothesis testing, which is where we're given some statement and we're trying to prove if it's true or not against our own type of side experiment. Introduction. For this section, we can use hypothesis test for proportion. Um, and this is used when politicians want to know the proportion of their constituents who favor a certain bill, or when quality assurance engineers test the proportions of parts that are defective. So very important. Recall from section 6.3 and 5.5 for normal distributions, the two inequalities must hold true. And this is when we're working with proportions in order to assume it's a bell shape. N times P have to be greater or equal to 5, and N times Q have to be greater or equal to 5. Most importantly, we're going to use the same inequality from section 7.2. This is in page 363, and this helps determine whether our null hypothesis, whether we want to reject or fail to reject. These are our two inequalities. If P is less than or equal to alpha, you reject your null hypothesis. And second, if P is greater than alpha, then you fail to reject the null hypothesis. And I put that in quotations because that's the verbiage you want to use. You never say accept. Remember, use reject or fail to reject. All right, these are our steps if you wish to do it by hand, but I encourage you to use your calculator. Your formula z-test for proportions. The z-test for proportions P is a statistical test of our population proportions. The z-test can be used when a binomial distribution is given, such that n times p is greater or equal to 5 and n times q is greater or equal to 5. The test statistic is the sample proportion p hat, and the standardized test statistics is z is equal to p hat minus p over q times p over n. And these are your steps if you wish to do it by hand. First, you want to make sure that it's normally distributed, either that statement is given, and if it's not, you want to make sure that n times p and q times n are both greater or equal to 5. With all hypothesis tests, 2, you want to state your claim, and from there identify your null and alternative hypothesis. Specify the level of significance, your alpha. Determine your critical values. Determine your rejection regions. So your critical values will be found from your t-test or your z-test above. That will give you a z-score, which you can use to change proportions. And then you would draw a bell-shaped curve to see whether it falls in the rejection region or not. Find the standardized test statistic and sketch the sampling distribution. That's 6, and there's your formula. And 7, you want to make a decision to reject or fail to reject your null hypothesis. And lastly, you want to write an answer using the words of your claim of your problem. We'll be using a calculator. Here are your steps. You want to press Stat and scroll until your test is highlighted. You want to choose one prop z-test. It's about the 5th or 6th option. You want to choose that, highlight it, and press enter. And then you want to fill in these values. P naught or P sub 0, and that's your claim, your proportion claim. And then you want to fill X and N. This can be given as your successes and your sample size. If not given, you might be given a percent. If given a percent, make sure to multiply it by your sample. If it's not given, your other option is to write your percent over 100. because remember your percent is just a proportion in correspondence to whatever you're working with. And then you want to choose your tail. Two-tailed, right-tailed, or left-tailed. Two-tailed is not equal to right-tailed and left-tailed. And again, if you're unsure, you can always look at your HA. Lastly, you'll press calculate to find your answer. Let's do an example. A researcher claims that less than 45% of US adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 1,000 adults, 41% say that they use passwords that are less secure because complicated ones are too hard to remember. At a confidence level alpha of 0.01, is there enough evidence to support the researcher's claim? All right, so just as before, we want to start off with our claim, and that's going to help us determine our null and alternative hypothesis. All right, so our claim is that less than 45%. So less than 45%, we write it as a decimal. So therefore, our claim gives us our HA. P is less than 0.45. Our alternative is now P is greater than or equal to, remember opposite sign with the equal sign, 45. All right, so now we're left to use our calculator. We want to fill out these pieces. So remember, to get there, you want to press Stat. Make sure Test is highlighted. Then you want to choose one prop, Z-test. You want to fill out your proportion from your claim, and then your X and your N that's given. Then you want to choose your tail. In this case, our claim tells us that we have 0.45, but we have to do some work for X and N. We want to create a sample, and we're told that with 1,000 samples, we have 41% that go along our claim. All right, so we have to do some work. We have to multiply 41% times 1,000, and from there we get 410. So now we got the proportion with 410 over 1,000. So we have an X of 410, and our sample is 1,000. Now, you could have also just used our 41% from our conclusion. We could have written that as 41 over 100. That would produce the same answer. But if we want to use the 1,000 given from our sample, we just multiply it to our conclusion, which is 41%, which is what we did above or below right here. Lastly, we have to determine our tail. Because our HA is less than 45, we want to choose a one that looks like this, a less than the PO. And again, if you're unsure, you want to look at your alternative hypothesis. All right, you press calculate, and be careful because you're giving your P hat, which is what you have here. I'm sorry, your P naught, or your P hat. I'm sorry, your P hat's this. It's going to tell you your P hat and your P. We want P, not P hat. Our P is 0.21068, and we can round it to 0.21. That's what we want to compare it to our alternative. Now you want to write P and alpha and compare it. We have that written above. You have two options. If it's greater than, you fail to reject. If it's less than or equal to, you reject. Our P is 0.21, and our alpha is 0.01. All right, which one's bigger? 0.21 is bigger, right? So our answer is we failed to reject your null hypothesis. Let's continue with our next example. A researcher claims that 51% of US adults believe incorrectly that antibiotics are effective against viruses. In a random sample of 2,202 adults, 1,161 say antibiotics are effective against viruses. At alpha equals 0.10, is there enough evidence to support the researcher's claim? All right, so you want to start off with your claim. That will lead to your null and your alternative. Our claim is that 51% believe incorrectly. So this one's really tricky because we have incorrectly, it's going to be not equal to. So our claim is p hat is not equal to, we're comparing against 51%. All right, and that's giving us our alternative. So we want to write p hat is not equal to 0.51. And so that leaves our null to be it's equal to 51. All right, we have our sample size and the number of successes. Let's go ahead and fill in our information. So we're going to use our calculator. You want to press the button stat and scroll until test is highlighted. Then you want to choose, scroll down until you find one prop, Z test. You want to put those pieces. Your P, your P0, P sub 0, your X and your N, and then your tail. All right, in our case, our P hat is 51, our X and our N. All right, so our sample size, our N is 202, and our X is 1,161. And what kind of tail is it? You always want to look at your alternative. So it's two tail. So we want to choose the one that looks like this. And I'll leave the note again. Look at the ha. All right, you press enter, and we want to work with our P. You're also going to be given a P hat, but that's not what you want. So your P is 0.10543, something like that, right? But we only want to work with maybe 2 decimal places, so we can round to 0.11. Now you want to compare it to your P and your alpha. Our P is 0.11 and our alpha is 0.10. What inequality makes the statement true or greater than? Because it's greater than, we fail to reject your null hypothesis. Your null hypothesis. And lastly, you want to go ahead and write a sentence about how you fail to reject your claim using the words of your question. All right, that's it for this section, and this summarizes null hypothesis. Hypothesis testing. You'll have a test on hypothesis tests, so look for that on Canvas. And I believe that's it for this week. I don't think I wrote a discussion board. All right, have a nice day. If you have any questions, please make sure to post them in our discussion board or email me. Thank you.